it going tonight? I wanted to talk about the chain rule and multivariable functions. So this is a function that will have, it could be f of xy or f of xyz, up to as many variables, and it can be noted simply. So let's say your function is like f of x, y, z. All these things, x, y, z within the argument are going to be each their own functions. So let's say, for example, we have f of x1, x2, and so on till, however many xn's of arguments we have. They're all going to be functions of a different variable t. So x1 is equal to the function of t, one certain function of t, x2 is equal to another certain function of t, and x3, another different function of t. So we can write this all together in one larger function as a function of exactly the same way, but we just note it differently. So the function 1 of t, the function 2 of t, and so forth till the last function that we're given. And we can write this simply by denoting it as z. We can just put gt is equal to z just for simplicity to note our derivative. So dz over dt is equal to the sum of the partial derivatives of z with respect to each entry, and then multiplied by the derivative of each x, which are each of the functions with respect to t. So you're going to multiply the inner part by the larger scale function. So we can do an example here. Hopefully that explanation makes sense, but the example really helps. So we're going to find df of dt at t is equal to pi. So we'll solve actually for d is equal to pi, where f of xy, you see our two variables there, is equal to x cubed ln 2 plus y squared, where this is our kind of our chain rule application is x is equal to the cosine of t and y is equal to the sine of t. So now you see we have the function inside the function. So this is kind of where we're going to start taking partial derivatives. And this is an application of partial derivatives. So first we take the partial derivative of the whole function with respect to x and with respect to y. Just remember that. The first part is the whole thing. So the partial derivative of the whole function with respect to x is 3x squared. And this just stays because that's just going to be a constant in this case. And then the y goes away because that's going to be a constant. So when we integrate, when we take the derivative with respect to a constant, it just goes to 0. And then here, partial derivative of the function with respect to y, we're going to have x cubed, the constant, 1 over 2 plus y, the derivative of ln, and then we have to multiply, of course, by the chain rule using the simple chain rule, which is just 1, so we don't have to write that, plus, and then we take the derivative of the last argument here, which is 2y. So now we have that. We know from this here that our df, I'm going to write it here, df, derivative of derivative of the function with respect to t is going to be equal to f of x dx over dt plus f of y, the partial derivative of y, multiplied by dy dt. So now we just have to memorize this here, and that can go on for as many variables we like to. We can add, if there's a z variable, we can add f of z and then dz over dt if there was like z equals tan of t. So now we have to find the derivative of x and y. So right here we can do that. The derivative of this here is going to go to negative sine of t, and of this here, that's just going to go to cosine of t. Now we just plug it in pretty simply. So we just write down the first partial derivative ln 2 plus y, multiply the whole thing by negative sine of t, plus, and then we'd use this here, the partial derivative. So I'm just going to multiply it in here. So x cubed over 2 plus y plus 2y. And this part here is all together, multiplied by the cosine of t, the derivative of y with respect to t, and this part's all together too. So now we have to plug in, since we took the derivative, now we can plug in x and y into this function here. So we can plug in 3 cosine squared of t ln 2 plus sine t, and then multiplied by negative sine t, plus, and then we have cosine cube t over 2 plus sine t plus 2 sine t multiplied by cosine t. So now our function is only in with respect to t. And now to get at t is equal to pi, to find our rate of change, our derivative, we can just plug in pi. So when we plug this in here, we're going to get negative 3 times 1 times ln 2 times 0. So that's just going to actually just cancel out. This pretty much just cancels out there. And then we have to add, let's see what this is. Negative 1, 2 plus 0 plus 0 multiplied by negative 1. So let's simplify this here. That's going to be negative 1/2 times negative 1. It's going to be equal to 1/2. So there's our derivative at the point t is equal to pi of the function x cubed ln 2 plus y squared. So just remember, partial derivative of x multiplied by x by the derivative of x with respect to t, adding the function partial derivative of y, and multiplying it by the derivative of t with respect to y. This is the most important, and you can add as many variables too as you'd like to this. It'll just kind of get long and messy, and sometimes you won't even have to find a point. You can just solve to here and you'll be good to go. Right on. Good luck. Thanks for watching. Like and subscribe.